So today we will be taking you through the Infrahub platform. I'm going to do that by showing you how you can make a change to an existing network in Infrahub. In the first phase of this demo, we will do this change manually, and I will take you through the process of how to do it manually within Infrahub up to the point where we can merge a change back into main and deploy the configuration artifacts to devices. In the second phase of the demo, we will abstract that workflow into a service where we will take a design-driven approach. So we will be creating a service instance and then leverage Infrahab's generator feature to create all of the downstream or lower level implementation objects that we need to fulfill the service, and then show you how we can get to the generated configuration artifacts for the devices as well. The change that we will be making today is adding a backbone link to an existing network that we have already modeled in Infrahub. All of the models that you see, for example, on the screen, you are seeing a list of devices, are all created using our flexible schema. All of the models that we will be using throughout this demo are available in our repository. They are there as an example for you to see what a schema could look like, but it also allows you to be a foundation to build your own schema, or if you don't like the schema, you can create one yourself. But everything is completely flexible. That's the main point. Also, the menu on the left that you see is generated based on that schema. So if you change your schema, then this menu here on the left will be completely different. All right, let's start making our change. So the first thing that we will have to do in Infrahub is create a new branch, which is going to create an isolated environment in which we can make our changes without affecting the main branch. So we'll be making a branch called change manual. This is an extremely lightweight operation. As you can see, the branch was created immediately. In the backend, we are not copying data or those kind of tricks. A branch is exactly what you are familiar with from Git, and you can have multiple branches simultaneously within the system. So we have created our branch, and we can now start to make changes. The first thing we will do is create a new circuit, which is going to be the foundation of the new backbone link. We will provide a circuit ID. For us, this is going to be an internal circuit ID that we use within our organization. We will have to provide a provider ID for the circuit. We are going to assign it a status, a role, and we will create a relation to the provider of the circuit, which is Lumen in this case. So we have created the object now. It shows here in the list of available circuits in the database. If I switch back to my main branch, you will see that that circuit does not yet exist in the main branch. So let's navigate back to the branch where we are making the changes, and you will see that the circuit pops up again. The next thing that we will have to do is connect the circuit to the interfaces that will host the connection on the network devices. To do that, in our data model, we will have to create what we call circuit endpoints, which allow us to connect a circuit object to interfaces on the device. I could do that in the UI, but it would take me some time to do that, and I don't think that's particularly interesting. So it allows us to showcase another feature within Infrahub, which is the GraphQL API. The GraphQL API is an API that we expose to our users, which allow you to make all of the changes to the data in Infrahub. The queries and mutations that the GraphQL API expose are again dynamically generated based on the schema that you load into the system. So if you provide your own schema, you will have completely customized GraphQL API mutations and queries. In this particular mutation that I'm showing on the screen, we are going to create two circuit endpoints. The first mutation is going to link my circuit to an endpoint, which is the ID of an interface on a device in the Atlanta site. And then the other end of the circuit will be connected to an interface on a device in the Denver site. notice that this GraphQL query or mutation is going to be executed within the branch as well. So I'm going to execute my mutation in the branch. So I've now created the circuit endpoints that connect our circuits to the interfaces on both ends of the circuit. So I can now go back to my circuit in the database. We can now see there's two endpoints for this circuit, and we can navigate to them. So one of them is going to take me to interface Ethernet 7 on the device Atlanta 1H1. And we can see that it's connected to the circuit below. We're going to make additional changes to this interface. For example, we're going to set the role of the interface to backbone, and we will be assigning an IP address to this interface. All right, then we are going to navigate to the other end of the circuit, which is in Denver Ethernet 7 on device Denver 1H1. We're going to make the same changes. So we will be assigning the role backbone, and we will be adding an IP address on this interface. All right. So now basically our change is done from a source of truth perspective, from a data perspective. We are ready to propose this as a change to the rest of our organization and start the process to merge this change into the main branch. In Infrahub, we can do that using a feature that we call proposed changes. Proposed changes are very similar to the GitHub pull request process. So it basically is going to ask you to provide the branch that you want to merge back into main and allow you to add some additional contextual data like title. So let's name this one add platform link. We can add more description about the change and even select a list of people that are supposed to review this change. We're not going to do that in this demo though. So create the proposed change. Within the first few of the proposed change, you get some details about which branch you are merging and some more other contextual data. But you could also start to have a conversation with the rest of the team surrounding this change. For example, let's post a quick message that the change looks good to us. So we could have a complete conversation here. On the data tab, we will start to see what has changed in the database from a data perspective between the two branches. So we effectively get a diff view from the data point of view. So what you can see here is that Infrahub is telling us that in this branch, we added a circuit with particular attributes and relationships. We will also see that we added the circuit endpoints that we created using the GraphQL API, as well as the changes we did in the UI for the interfaces. As Infrahub also has a feature called transformations, which allow you to change the data in Infrahub to some other output format. In this particular case, we have used transformations to generate configuration artifacts for our devices. If we expand on them, we can basically see how the data changes have affected our configurations. So the configurations have been regenerated based on the data that was changed in the database. And we can see that the intended configuration of Ethernet 7 has now changed. We basically added the description that this interface is of role backbone. We add the IP address to the interface. We configure it to be a layer 3 interface, and we add it as a point-to-point link to OSPF. The same change has happened for the other device. So these are Jinja2 transformations that we used in this particular case, but we can also use Python transformations to generate other types of artifacts. In this particular case, we used a Python transformation to generate an OpenConfig payload, which is the equivalent of the text change that we did above. Notice that within this proposed change, you will only see artifact updates for the devices that were affected by the data changes. We do not regenerate the configurations for devices for which we don't need to regenerate it because the data was not modified for them. Then, as part of this proposed change, we also ran a CI pipeline. In this particular change, we ran a few tests. The first test that the system has run for us is a data integrity test. It is checking basically that there is no data conflicts or merge conflicts that we created within our branch. We also have artifact validators that are basically going to validate which artifacts need to be regenerated and whether or not we can generate those artifacts successfully. If those artifacts would fail to properly be generated, then the pull request or the proposed change would be blocked from being merged. Finally, we also allow you to provide user-defined tests or checks. In this case, we have added a check to Infrahub, which is basically going to check that every site within the database has enough redundancy to the backbone network, redundant connectivity to the backbone network. It's basically a business rule that we need to have some level of redundancy. If you make changes to the database that would break that rule, then we would block the proposed change from being merged. So that concludes the change. We have gone through the proposed change. Everything looks good. We can now merge this change back into main. So if I now go to my main branch, you will see that for example, the circuit object now exists within main. It is connected to the two endpoints, which are interfaces on the devices, and they have the correct configuration and the IP addresses have been assigned to them. Great. So now we could consider this to be a fairly standard change in our network, and we could say that we want to allow other people to make these changes, and maybe those people are not that network or are not that skilled in networking, so we want to expose it as a service to them. So within Infrahub, we can do that by using the generators feature. So the first thing we have done is created a model in which we can basically model this as a service. First thing I'm going to do though is again creating a branch because I'm going to make changes to the database. Let's call it change generator. So we created a new branch, and the first thing we are going to do is create a new instance of a service object that represents the service that we want to implement. I called it the backbone service. This backbone service is going to ask the user or the consumer of that service to give us some input details, like the circuit ID. So let's give it a circuit ID. Let's give it an internal circuit ID. Let's give it a name, backbone, the provider of the circuit that is going to make up this service, the first site which we want to connect using the circuit, let's take Denver 1, and the second site, which is going to be DFW1. So we created the service instance. We need to add it to the service instance group. So let's add it to the backbone services group here. So now basically we have added the service instance and we need to create a proposed change. Change, let's create a new one. We will pick the change generator branch and we will give it a name. And we will create our proposed change. So now in this proposed change process, the generator is going to run. And we can already see that it is in progress here. So basically what it is going to do is going to pick up any new service instances that have been created within Infrahub and pass those onto the generator. The generator will then basically create all of the downstream objects following the business logic that you provided according to your design. Let me refresh the screen to see if it has already finished. It already finished. So let me take you through the proposed change again. We see the overview of the data that is being provided around the proposed change. On the data tab, we will start to see the changes that have been made by this generator. You can see that, first of all, we created the backbone service object, and then all of the other changes are basically done by the generator itself. You can see here that we created a circuit called diff 5678 with particular attributes and relationships. We can see that the generator has allocated a new prefix that will be assigned to the circuit. It has assigned IP addresses out of that prefix that we are going to use for the interfaces that are going to be connected to the circuit. And then we will see that it has used a business logic to allocate the right service. That use a business logic to allocate the right interface that should be connected to our service and has assigned an IP address to it. So if we now go to the artifacts tab, we can already see that, again, the artifacts have been updated for the devices that were affected by this change. So in this particular case, we can see that Ethernet 3 was modified. The IP address that we saw in the data change has been assigned to this interface. We convert the port to the layer 3 interface, and it has been added to OSPF. The same thing happens for the other end of the circuit, which is the interface on Ethernet 3 on the DFW side. And then we also generated the same OpenConfig payload again. The CI pipeline has run, basically validating that all of our changes look good. We didn't create any conflicts. The backbone service generator has run and created all of its objects. We have successfully regenerated our artifacts, and the user-defined check for the backbone link redundancy has succeeded. So again, we are ready to merge that change back into main. Now, if you would need to start lifecycling this object, it is very important that we can track which objects that service is responsible for. And we can basically quickly do that by going to the groups in Infrahub, and I can quickly identify the group that was created because of the generator that run for our service instance. And within that group, we can now see that all of the objects that our generator has run have been gathered into a group. And this is a way for us to start tracking basically all of the objects that this service instance is responsible for. So we can now basically start to do changes to the service. And then our generator will know which objects we need to touch because of that change. All right, that kind of concludes the demo for today.